Hey guys, here is 11.4 logarithmic functions. We're going to be popping between the book here at the beginning, but I will send this all to you as well. So here we go. So see tables and graph on page 718. So we're going to look at this graph down here. Okay. In this picture, we have the information out so that we can graph the exponential function, right? So the question is what happens when we switch our x and y and we get the inverse of our exponential function? Well, here's our inverses. We switched our x and y's. We get this function down here, okay? This function right here is represented by something that we know as the logarithmic function. So this kind of is a proof to you why exponential functions and logarithmic functions are inverses of each other. I just wanted to talk about it briefly. I'm not going to go extremely into it. You are welcome to if you want to. So back to our notes. Okay. Logarithmic functions, this is the definition. So if y equals log base a of x, a has to be greater than 0 and not equal to 1, its inverse is y equals a to the x, so that y equals log base a of x is if and only if x equals a to the y, right? This isn't as important as this information right here, okay? So it's important to know that this and this are equivalent to each other, all right? So this piece right here, this y, is also this y. This piece is called, this is the exponent, okay? This piece right here, and this piece right here, we're gonna go wide on this one. This is gonna be our base. All right, and this piece, and you'll see that actually is all that matters. That's the only piece that matters. So this y is our exponent. It pops down in front, and then this right here is the base of our exponent. Okay. So right here, these two are equivalent to each other. Y equals log base 2 of 32. So this y is our exponent. This 2 becomes the base of our exponent, and this number becomes the equal. I'm trying to find, I had a colorful pen around here somewhere. Color is this? Oh, that's not helpful. Thank you. I needed a colorful pen. All right, found a blue. I don't know where my green one went. We'll find it eventually. Okay. All right. So since, let me back up. Knowing these two are equivalent will help us be able to solve logarithms or help us to get rid of exponentials that we don't know. Okay. Since 2 to the 5th power equals 32, right here, y equals 5. So log base 2 of 32 equals 5. Give you a second to kind of digest that while we're having an earthquake. All right. okay? Something to bring up and mention right now, and I'll bring it up again later. The log button on your calculator is a base of 10. So you cannot just plug this into your calculator. We don't have a way right now to just plug that in. All right. All right, onward. Okay, example. Write each equation in exponential form. Okay, so let's just break them down. This right here, this is going to be our base. This right here is going to be our exponent. Okay, so we're going to go 125 to the 2/3 power equals 25. If we actually solve this, it would be 25. All right, on here, same thing. This is our base. This is our exponent. This is our equals. I'll draw an arrow so you're going to see where it goes at the end, okay? So really what we're saying is the cube root of 8 equals 2. We know that's true. All right, write each equation in logarithmic form. All right, so we're going to take now this concept from up here and go back the other way, okay? So we'll have this right here is our base, and this is going to be the equal to, okay? So we'll have log base 4 of 64 equals 3. Okay, same thing, base. So this is going to be log base 3. This exponent is going to be our equals to. So this goes next to the log. All right. This is a concept that we can use to evaluate our logarithmic expressions using the fact that if a to the u equals a to the v, then u equals v. You can use that to evaluate a logarithmic expression. So what we're going to do, whoopsie doodle, let me rewrite this for you. This should say log 7 of 149. There should be no equal there. Okay, so what we're going to do is we're going to say that x equals this. Okay, we're going to work our way to solve to find out what x, or what this logarithm really equals. Okay, so we're going to write this now in our form from above. So we are going to say this right here is our base. So we're going to say 7. This is our exponent. Is going to equal 1 over 49. Okay. We know that we could rewrite this as 49 to the negative 1. Okay, so we're kind of working backwards. We know that 49 is the same as 7 squared. We could use our power of a power rule to get that to there. So we know that in the end, x is going to equal negative 2. So we set up an equation using what we know, and then we tried to work our way to get similar bases so we could make their exponents equal. All right, next page. Okay. So another thing to talk about, since logarithmic and exponential functions are inverses of each other, both of their compositions yield identity functions. So we're going to say that f of x equals log base a of x, and g of x equals a to the x. Okay, so what we're going to do is we're going to do a composition of functions, and in order for f of x and g of x to be inverses, when you put them into each other, the final answer must equal x. So we're going to experiment with that. Okay. All right. So for f of x, we are going to put g of x where that x is. So we're going to do log a to the x. Does that equal x? Okay. Let's solve and see. Okay. Log, let's see, we could go x. That's a new rule we don't know. Log a and a, this cancels each other out to become a 1. So all we have left is an x equal to x. Okay, and then over here we would have a to the log a of x equals x. Well, a to the log a, can they cancel each other out? We're going to have that x is equal to x. So in order for them to be inverses, they have to composite. So that brings us to our properties of logarithms. Okay. So on these properties, we're going to assume a couple things. M and N are positive numbers. B is a positive number, and B cannot be 1. P can be any real number. Okay. So first property is the product property. So what it says is if two numbers are multiplied together inside of the logarithm, it's the same as pulling them out and adding them together. Okay, so log base b of m plus log base b of n. Here's an example for you over here. The quotient rule says if you have numbers divided by each other, we can pull out the logs and subtract them. Okay, they're kind of similar to exponent rules, interestingly enough, because they are inverses of each other. So here, right here, can see an example form. Power rule. If you have something to a power inside the logarithm, you can take this power out in front, okay, of your exponent. So here's your example here. This helps us to get x out of the exponent, which is what our goal is. Okay, so we can solve for x. And then the equality rule says that if we have logs with the same base equal to each other, then their numbers inside are also going to be equal to each other. So nice little example here. We have log base 8. So that means their insides are equal to each other and the logs can go away. Okay, so let's try out some problems using our definitions. Okay, so we have log base p. We need to figure out what p is, and because it's down here in this log, that's not really helping us out very much. So what we're going to do is use our definition of exponents to pull this out. So this is going to be our base, the p. This is going to be our exponent. Sweet. Okay. The next thing we're going to do is we could rewrite these. The square root of p equals the cube root of 64. Okay. We know that the cube root of 64 is 4. Now we can square both sides. And p is going to equal 16. All right, on to our next problem here. Okay. We'll notice right away that our log base is the same. Because they're the same, we can use this last rule. Okay, so that means we can say that 2x plus 11 equals 5x minus 2. Yay, we have easy algebra, so I'm going to add 2 to both sides. Minus this 2x on both sides. So I'm going to have 13 equals 3x. Okay, divide by 3, and my x is going to equal 13 thirds. Hey, guess what? I'm getting a low battery alert. Is that anything new to our class? I don't think so. Let me plug in really quick. All right, should be good now. Okay, last problem on this page. We're almost done. Okay. We have 2 logs added together. So we're going to use up here our, if we add them together, it's the same as multiplying them inside the logarithm. Okay. Because we have a log 11, so we can do a log 11 on this side equals a log 11 on this side. We can get rid of our logs. So I'm going to say log 11 x times x plus 1 equals log 11 of 6. Okay. At this point right here, we have, oh goodness, this is 11. Silly me. Okay, we have 2 log 11, so they'll go away. So we'll have x squared plus x equals 6. In order to solve for x, we're going to have to do a quadratic. We could find out that 2 numbers that multiply to make -6, but add to make a +1. So we know we'll have a negative, positive. We're probably looking at 3 and 2. Okay. See, 1, 6, 2, and 3. This one makes the most sense. We have positive x, so we got a 3 and a 2. So x plus 3, x minus 2. So x is going to equal 2, or x is going to equal -3. Okay. All right. If you have a situation like this where you have multiple equations, we could take a look at these. In our rules above were m and n allowed? Well, let's see. X would go in here, right? On our rules above, were m and n allowed to be a negative number? It says, suppose m and n are positive numbers. Well, that means that this answer right here, not possible. So the only possible solution here would be this one. So make sure that you look up at your rules, make sure an answer you have is a possibility. Okay, one more. Just want to talk quickly about graphing logarithms. If you have a logarithm base 10, this is a 10, you can throw it on your calculator and graph it. If it is not a base 10, okay, you have to use another form to graph it. These are not going to be highly important. This is not what I need you to know for the future. So we're going to talk briefly about it. You'll have one to practice on your homework because I want you to see it, but we're not going to go deep into this, okay? So the first thing that you would do is you would write this as an exponential. So we would say 3 to the y equals x plus 1, okay? The next thing that we would do is we would choose a couple values for x and y. So we would do, we would find out what y is, we'd choose some y's, we'd find out what their corresponding x's were, and then we would graph them, okay? We know that nothing. So what we're going to do is maybe I'm just going to pick, I would say that when you choose points that maybe you need 0 and then maybe 5 total. So 1, 2, -1, -2, okay? So you're going to plug a 2 in for your y, and you're going to solve for x. And then you'll plug a 2 in, okay, etc. So when you plug a 1 in, you're going to get a 2. When you plug a 2 in, you're going to get an 8. When you plug a -y in, you're going to get a -0.67. And when you plug this, -0.89. Okay. All right. So what we're going to do then is you can take those points and plot them on your graph. Okay. So these numbers are, let's see. Okay, one thing to notice, these are in y, x form, okay? Because this was up here, that made the most sense to plug in for that. I didn't even think about the fact that I was doing that in a weird order. So you could have done that in a different way. Oh, if you plug in 0, sorry, you get 0. So 0, 0 is your first point. Okay, your next point is going to be 2, 1. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 2. -0.67, -1. Okay, my graph's going to look something like this. So there you go. Okay. Yep, that's right. Okay. So that works for me as a graph. But the way to graph these is to plug in points. There's only one on your homework, just so you have some practice doing it, because you can't just plug it into your calculator. All right? Okay, so homework assignment, page 723, 21 to 53 odd. This is due next Wednesday because we don't have class till then. We will also have a Zoom check-in at 11:15 on Wednesday. Okay, that's kind of going to be our Zoom check-in time. I will continue to just be recording these and posting them for you. Please let me know if you have any questions, and I will chat with you later. Bye.